Although capable of cutting thicker materials, thermodynamics contends that the cut rate should reflect the thickness that the system is more than capable of cutting. You wouldn't tow a 1-ton load without adequate horsepower. Why not have the same assurance with your plasma cutting system? This is the philosophy of the Cutmaster True Series. The Cutmaster 39 is a 30 amp machine that runs on 110 or 230 volts. It has a 35% duty cycle and a true cut capacity of 1/4 inch. As in all Cutmasters, it is intended for aluminum, stainless, or mild steel cutting. The Cutmaster 39 is well suited for automotive works, plumbing, heating, and air conditioning. New to the Cutmaster 42. This is a 40 amp machine that runs on 120 or 230 volts. It has a 40% duty cycle with a cut capacity of 1/4 inch. It's the perfect solution for auto and marine repair, home shop use, metal building, and roofing construction. The Cutmaster 42 features the all-new SL40 torch, based on the proven Sherlock platform. Like other Cutmasters, the Cutmaster 42 comes with our industry-leading standard 4-year warranty. The Cutmaster 52 is a 60 amp multi-voltage system. It's able to operate on a range of voltages from 208 through 460 volts. Dedicated systems are 400 volts CE or 600 volts. It has a 40% duty cycle and a true cut capacity of 1/2 inch. This would be the system of choice for construction, industrial maintenance, or fabrication. The Cutmaster 82 is an 80 amp multi-voltage system. It's able to operate on a range of voltages from 208 through 460 volts. Dedicated systems are 400 volts CE or 600 volts. It has a 40% duty cycle and is considered a 3/4 inch capacity system. The typical application for the Cutmaster 82 would be pipe cutting, including precision bevel cuts using the proper accessories. The Cutmaster 102 is a 100 amp multi-voltage system that is capable of operating on a range from 208 through 460 volts. Dedicated systems are 400 volts CE or 600 volts. It has a 40% duty cycle with a true cut capacity of 1 inch. The Cutmaster 152 is a 120 amp multi-voltage system which is able to operate on a range of voltages from 208 through 460 volts. Dedicated systems are 400 volts CE or 600 volts. It has a duty cycle of 60% and a cut capacity of 1 1/4 inch. The Cutmaster 102 and 152 are great for heavy-duty fabrication and manufacturing applications. Automation systems can range from the relatively lightweight, portable Cutmaster A series to the large-scale, high-output UltraCut, AutoCut power supplies. They can be divided into 3 categories: light-duty automation, high-precision automation, and conventional automation. The light-duty automated systems include the Cutmaster A40, Cutmaster A60, Cutmaster A80, and Cutmaster A120. The high-precision automation category is comprised of the UltraCut series. All UltraCut high-precision systems include the water mist secondary for excellent weld-ready cuts. Standard with the UltraCut systems is the XT torch with the Speed Lock rapid engagement feature. Conventional automation is made up of the AutoCut series of systems. These systems are 100% duty cycle, dual gas machines that are intended for general purpose automation. AutoCuts come standard with the patented XT301 torch with its patented Speed Lock rapid engagement system.
Let's discuss what plasma is and how it works. For an example of matter converting into its various states, consider H2O. Here we see a solid in the form of ice. As the temperature increases, the molecular structure changes the solid into a liquid to form water. As the temperature continues to increase, the liquid becomes a gas, in this case steam, that dissipates into the air. When air molecules are subject to extreme heat, such as an arc of electricity, the molecules become ionized, resulting in plasma. In order to harness this energy for cutting metals, we begin by forcing a gas, such as air, into a chamber in the torch head. The gas pressure opens a valve called a start cartridge that also acts like a switch, resulting in an electrical spark provided by the power supply. The gas becomes ionized plasma as it passes through the arc. Forced through an orifice in the torch tip, the electrically conductive plasma will jump to the work surface when it is in close proximity. This completes a circuit that the power supply detects, thus providing the required output for cutting the material. The manual systems are also divided into two different categories: internal air systems and external air systems. Internal air systems are low current output power supplies with a built-in air compressor for handheld operation. External air systems require an outside air source, such as a factory air compressor or bottled air.
Our internal air systems are defined by the drag gun series. The drag gun consists of a 12 amp power supply that operates on a 120 volt input. This system has a 30% duty cycle. It is referred to as a 1/8 inch system, a designation that represents the maximum recommended cut thickness. This system comes standard with a PCH-10 torch. The drag gun is intended for thin gauge metals such as ductwork, particularly where mobility is important.
The Drag Gun Plus is a 35 amp half-inch machine that runs on 230 volts and has a 35% duty cycle. The Drag Gun Plus contains a humidity removal kit. The Drag Gun Plus comes standard with the PCH-42 torch. This is the system of choice for applications requiring both portability and a bit more muscle than its smaller cousin. The external air systems begin with the Cutmaster True series. In order to get started, it is important to know and understand the power requirements of your Cutmaster. Refer to the operator's manual for a more detailed list of setup instructions. First, determine what voltage your machine will be running on: 110, 230, or 460 volts. Once the voltage has been determined, make sure the proper amperage-rated breaker is available. Using the chart on the rear of the machine, read the maximum current that corresponds to the voltage that you will be using. The circuit breaker should be rated at or above this maximum circuit number. Now that you have determined the voltage and power, make sure a properly rated plug and power cable is connected for the application. All Cutmaster models, other than the Cutmaster 39, have a voltage selection switch located on the rear panel. One position is for 208 and 230 volts, and the other is for 460 volts. When plugging in or removing the cable, be sure the breaker that is providing the power is in the off position. Plug the power supply into the receptacle. Once the plug is fully engaged, it is safe to turn the breaker to the on position. Note: never insert or remove the plug from the supply voltage without first making sure the breaker is in the off position. It is now time to hook up your air supply. Thermodynamics recommends that you use clean, dry air from either a standard air compressor or gas cylinder. The air is connected at the rear of the power supply. Read the label on the cover to understand the pressure and flow requirements of each system. Next, determine what amperage you're going to be cutting with. Each unit has an adjustable control knob on the front panel that controls the output current of the system. For thinner gauge materials, use a lower current setting, and for thicker materials, use a higher current setting. Refer to the cut charts located in the operator's manual for specific cutting currents and recommended amperage rating. Once the amperage has been selected, be sure to install the appropriate tip into the torch. Each tip is marked with the proper corresponding amperage. All SL60 and SL100 torches use a standard set of consumables for all current ranges. When switching current levels, the torch tip is the only consumable that requires changing. To properly install the tip, begin by pressing the electrode firmly into the torch head and snapping it into place. Next, place the start cartridge onto the torch head over the electrode. Place the tip onto the start cartridge and over the electrode. Attach the shield cup by fully tightening it over the assembled parts. After the torch parts are installed, attach the torch to the power supply. All Cutmasters come standard with the patented ATC connection, which allows instant connection or disconnection of the torch to and from the power supply. Now that the air and power are connected, it is time to turn the power supply on. After about select the system compatible with the application. Follow standard safety procedures. Use proper eye and hand protection as well as protective clothing. Make certain that the torch is properly assembled with new parts. Older worn parts left in the torch from a previous project may be at the end of their usefulness. Use a sturdy table or bench that is waist high or higher for control during cutting. Steady your body by leaning against the table surface. Use a 5 to 10 degree leading torch angle. This will minimize dross. Maintain a smooth travel speed with the plasma arc trail following at a 5 to 10 degree angle. Always pull the torch towards you rather than pushing it away, using your shoulder for movement rather than your elbow. Torch standoff should be 1/8 to 3/8 inch or 3 to 10 millimeters above the cutting surface, depending on the size of the system. To cut a quick straight line, use a non-metallic straight edge or roller guide for best results. Piercing and cutting an inside diameter circle using a non-metallic template is easily achieved with practice. Bevel cuts are also relatively simple, requiring an elevated straight edge to support the torch. More precise angles can be achieved using the adjustable angle on the roller guide. Use the circle cutting guide kit to cut a large circle or radius. This technique is usually mastered after only a few tries. Cutting expanded metal is easy with the autopilot restart feature. The requirements that are critical to your application will help determine what system and techniques are ideal. Typical critical requirements are speed. Use a drag cutting technique, tip on work, for cutting 1/4 inch material at 60 amps or less with a non-metallic straight edge. A standoff guide can be used for cutting above 60 amps as well as the drag shield cup for some heavier applications. Reduce distortion. Use drag cutting with or without a straight edge up to 60 amps. This will produce the narrowest kerf and minimize heat input. Quality. Fast, clean cuts are obtained on most metals.